4.5 billion years ago, Earth and Venus were almost twins. They were born from the same cloud of dust and gas. They formed at nearly the same time. They are almost the same size, the same mass, and made of nearly the same elements. And yet one became a world of oceans, life, forests, and breathable air. The other became a planetary furnace, hot enough to melt lead, wrapped in clouds of acid, crushing anything that touches its surface. This raises one of the most profound questions in planetary science. Why didn't the Earth become a Venus? Why did one world remain habitable for billions of years, while the other crossed a point of no return? The answer is not a single cause. It is a fragile chain of events, small differences amplified by time. And if even one of those differences had gone the other way, Earth might have become uninhabitable long before life ever began. Both Earth and Venus formed from the same protoplanetary disk, a swirling cloud of rock, ice, and gas surrounding the newborn sun. Gravity pulled material together, heat from collisions melted rock. Heavy elements sank inward, forming metallic cores. In their infancy, Earth and Venus were molten worlds, covered in global magma oceans. Volcanoes dominated their surfaces. Their atmospheres were thick with carbon dioxide, water, vapor, nitrogen, and sulfur gases. At this stage, they looked nearly identical. But one crucial difference already existed: distance from the sun. Venus formed just 30% closer to the sun than Earth. That small difference would change everything. Venus receives nearly twice as much solar energy as Earth. At first, this didn't seem catastrophic. Early Venus may have had oceans, perhaps shallow seas, or even global water coverage. But more sunlight means higher surface temperatures, and higher temperatures mean faster evaporation. As Venus warmed, more water vapor entered the atmosphere. And water vapor is not just a gas, it is a powerful greenhouse gas. This is where the feedback loop began. As Venus warmed, oceans evaporated. As more water vapor filled the atmosphere, temperatures rose even further. Higher temperatures caused even more evaporation. This positive feedback loop is known as the runaway greenhouse effect. Eventually, Venus crossed a critical threshold. At that point, no matter what happened next, the planet could no longer cool itself. The oceans boiled away entirely. Water vapor reached the upper atmosphere, where sunlight split water molecules apart. Hydrogen escaped into space. Oxygen reacted with surface rocks, and Venus lost its water forever. Earth stood dangerously close to the same fate. Earth was just far enough from the sun to avoid crossing that threshold. As Earth cooled, something remarkable happened. Water vapor condensed. Rain fell not for days or weeks, but for thousands of years. Oceans formed, and oceans changed everything. Liquid water acted as a planetary thermostat. It absorbed heat. It dissolved carbon dioxide. It enabled chemical reactions that locked greenhouse gases into rocks. Earth began to regulate its own climate. Venus never got that chance. Earth possesses something Venus lacks: active plate tectonics. As carbon dioxide dissolves into rainwater, it forms weak carbonic acid. This acid weathers rocks, carrying carbon into the oceans. Tectonic plates then drag this carbon into Earth's mantle. Over millions of years, Volcanoes release some of it back into the atmosphere. This process is known as the carbon silicate cycle. It acts like a planetary thermostat, stabilizing Earth's climate over geological timescales. Venus has no such system. Its crust is largely stagnant, a single, immobile shell. Once carbon dioxide accumulated in Venus's atmosphere, there was no way to remove it. Venus's atmosphere is over 96% carbon dioxide. Its surface pressure is more than 90 times that of Earth. Its clouds are made of sulfuric acid. Earth's atmosphere, by contrast, contains only trace amounts of CO. The difference is not chemistry, it is planetary regulation. Earth continuously recycles carbon between air, ocean, and rock. Venus does not. Earth has a strong magnetic field, generated by its liquid iron core. This magnetic shield protects our atmosphere from being stripped away by the solar wind. Venus has no global magnetic field. Once its water was lost and its atmosphere thickened, the sun slowly eroded lighter elements away. Earth's magnetic field helped preserve its oceans and atmosphere for billions of years. Life itself helped stabilize Earth. Early microbes consumed carbon dioxide. Photosynthesis released oxygen. New minerals formed, locking gases into Earth's crust. Life and planet evolved together. Venus never developed life, or if it did, it vanished quickly. Earth crossed another threshold that Venus never reached. Climate models suggest that if Earth were just a few % closer to the Sun, or if volcanic activity had released slightly more greenhouse gases early on, Earth could have entered a runaway greenhouse state. No oceans, no life, no recovery. Our planet survived by a narrow margin. Understanding Venus helps us understand distant worlds. Many exoplanets discovered today may be Venus-like, not Earth-like. Habitable zones are fragile. Small differences matter. Venus teaches us that habitability is not guaranteed. Earth did not survive because it was destined to. It survived because of balance, distance, water, geology, magnetism, time. Change any one of these, and Earth might have become another Venus. And that makes our planet not just rare, but precious. If this video helped you see Earth in a new way, please like and subscribe to the channel. Your support helps us keep creating clear, scientific stories about the universe we live in.